So I had a request for problems 7 and 8 from the related rates stuff. So I changed the numbers a bit. Probably this will be to my detriment, but we're going to give our best to do this with these numbers. We have a spherical balloon. The volume is increasing at a particular rate, and we want to know what's happening to the surface area at a particular point in time. Let me just draw what's happening here. We have this balloon. The radius is increasing, of course. So when we make this sort of snapshot, we see that the radius is 9. The volume, so I guess we could just pretend that this is like the valve or whatever, that there's air being pumped. Here we could say that this is a pump. And the air is going into the balloon. The change in volume with respect to time is 23 cubic centimeters per minute or second. And we want to know what's going on with the surface area. We're given the various formulas that we need. So one way to tackle this is to try to solve for V in terms of S or vice versa. That just is too much of a headache. I think what I'd like to do is just to do these as two separate related rates and then combine the answers at the end. So we'll start with dV over dt. Using this volume formula will be 4 pi r squared dr over dt. That means that 23. So I'm going to basically figure out what dr over dt is, and then I'll work that into the second equation. So 23 is equal to 4 pi times 9 squared, because my radius is 9 at this moment in time, dr over dt. And I guess this is going to be something really ugly. All right, well, I did this to myself, I guess. So 23, 4 times 81 is 364? No, 324. Okay, and there's a pi down there. So that's dr over dt. Now let's do this, figure out the surface area. So that gives us, that's the stepping stone that we needed. So ds over dt, using the formula for the surface area, is going to be 8 pi r dr over dt. We know what dr over dt is now. So ds over dt is 8 times pi times 9 times 23 over 324 pi. Looks like the pi's will cancel. 72 should cancel as well. Sort of. Some of it will cancel. So here, I'll write it down like this. 8 times 9 times 23 over 4 times 9 times 9. The 4 times 9 times 9 is the multiplication I did to get to 324. I didn't need to do that. Anyway, let's cancel some stuff, and we're left with 2 times 23, 46 on top. On the bottom, just 9, so 46 ninths, and that's in square centimeters per second. All done. Hopefully that helps you. Next one, I did this one, or I changed this one around a bit. We have a trough, which is 8 feet long, and its ends are isosceles triangles that are 7 feet across at the top and have a height of 2 feet. Let me see if I can draw this. That doesn't look good. Let's see, I feel like the triangle is the most important piece. There we go. That's a pretty nice triangle. Let's duplicate this and stick it up here somewhere. And then I'll just connect up the corners. Whoa. Let's undo that. There we go. Okay, connect up the corners. And then I suppose to make it look a little bit more realistic, we can get rid of this line here. There. But it exists. Okay, so there's our little water trough. And I'll put the measurements in here. This is 8. This is going to be 2. And this will be 7. We want to know, let's see, it's being filled at a particular rate. So dV over dt is going to be 13 cubic feet per minute. And we have inches here. So we're going to have to change that to feet. That's going to be 5/12 of a foot. That's annoying. Okay, but that's okay. So what I'm going to do here is I'm going to focus on this end of the trough, and we will, I should use blue for water. In just a minute, let me see if I can find some, there, that looks better. So we have our water level, and this distance is going to be the thing that is changing. We're going to call that x. And so I need to just be able to figure out how to compute the volume of that x. Now notice that this triangle that is made with the water, the green triangle, is similar to the black triangle. That black triangle is 7 feet across and 2 feet tall. The blue triangle, so 7 is to 2, as we'll call this distance here for just a moment, we'll call it y, y over x. But I just want y as a function of x, so 7/12 x equals y. And so that's what I'm going to have here. 7 halves x. The length of the trough does not change. It's always 8. So the volume now, the volume of a prism is the area times the length. So the area is the area of that blue triangle. The area of the blue triangle is 1/2 times the base times the height. Maybe I should write that down so that it's more obvious to everyone, because I know that you don't like geometry. 1/2 base times height times the length of the trough. Okay, so the length of the trough is just 8. So there's my volume. Let's see, I can cancel some stuff here, and you're left with 14x squared. Now, the rest of this is pretty rote. I'm pretty sure you can do the rest yourselves. Let's see, dV over dt we know is 13. 28 times, x here is 5/12, because that's the depth at this moment in time. And let's see if I can solve this thing. So let's see, 13 times 12 over 28 times 5 is dx over dt. Just some simple algebra here. Take your time, you can figure it out. And then I suppose I could cancel 28 is 4 times 7, so that's going to be 3 up top, 39 over 35. And I suppose that's going to be in feet per second. Is that what the units are? Yeah. Oh, feet per minute. Oh, it's all per minute. I've been saying second, but it's minutes. Okay. Hope this helps. Make sure you smash that like button.